our problem, we'll fill in all of these pieces here. So dE is k times dq over r squared. Sine theta is y over r. So dq was lambda times dx. Y is y. And r squared times r is r cubed. But r is x squared plus y squared to the 1/2. So that guy is all cubed. So if we take something to the 1/2 and we cube it, what we get is something to the power of 3/2. Okay, so that's where that 3/2 comes from. Some people tend to find that confusing. The other thing that throws people is that we have a y here and a dx here. That is absolutely right. This is correct. Just because we have a y on top doesn't mean we switch this to a dy. The dx comes from the fact that our charge has a little bit of length in the horizontal. So the dx is right and the y is right. So we're all good to this point. To keep going, we'll want to find our total EY by doing the integral of this business with the appropriate limits. So that's the part we'll get onto next. So EY equals the integral of DEY, which is the integral of k times lambda times y times dx. Normally you'd put that y in front of the dx. Divide, you don't have to, but that is a traditional way to write it. Y squared to the 3/2. So here we have our integral. Before we can go too much further, we have to evaluate the limits. So we're going to go from x initial to x final. How do we pick the limits of the rod? So let's just very quickly draw that rod again, because our initial picture is getting a bit crowded. So the length of the rod is L. We want to go from an initial point to a final point. We have to add up all the bits of length. So we want to go all the way along the rod. So we want to add up all these little bits. So this is going to be our x initial. This is going to be our x final. Or let's make this our x initial and this our x final. Doesn't really matter. Okay, so let's start from this end of the rod and we'll add up all the bits. So if the whole length is L, if this is our origin, if this is 0, then this is minus L/2 and this is plus L/2. These electric field problems, it's really important to take advantage of the symmetry and you put your axis right in the center of the rod there. So we're going to do the integral from minus L/2 to plus L/2 k lambda y dx side of x squared plus y squared to the 3/2. Okay, next thing we do is we take our constants out front. So what's constant? K is, lambda is, y is, minus L/2 to plus L/2 dx over x squared plus y squared to the 3/2. Okay, next part is going to be evaluating that integral, putting the limits in, and writing our final result.